Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Vampire und ihre Opfer by Blobs. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. There are also 9 vampires, digits 1 through 9 once each in the graveyard, which is the grid. So the grid is considered the graveyard. There are 9 vampires, which also contain the digits. So there are 9 vampire cells, which also contain the digits 1 through 9, exactly once each. There are also 9, and they are 1 in every row, column, and designated 9-cell region, or box. There are 9 victims, digits 1 through 9 once each, in the graveyard, which is the grid. And again, 1 in every row, column, and box. The value of a vampire cell is the sum of its digit plus the digit of the victim cell in the same box. So, for example, say you had a vampire here and a victim here. The value of this vampire cell would be the sum of the digits of its own digit and the digit that's in the victim cell. So, for example, if this were, say, a 7 and this were a 6, the value of the vampire cell would be 13, which is 7 plus 6. The value of a victim cell is always 0. So the value of this cell would always be 0. And the value of a natural cell is its digit, right? So that's the value of a normal cell would be the digit that's in it. Every coffin, which is a cage, a killer cage, contains either a vampire or a victim. So every cage must have a vampire or a victim here. And the total shown for each coffin is the sum. So every coffin contains either a vampire or a victim. It doesn't say anything about both. I'm assuming it's not both, but that's probably it's probably a safe assumption, but it's not specified. So you could technically by definition, since it says either a vampire or a victim, you cannot have both in the same cage. But we will not use that assumption necessarily. So in every killer cage, there's going to be a vampire or a victim guaranteed. It could technically have both because it's not specified. It's very unlikely to, though, because of the way that the phrasing is. So keep that in mind, though. But again, I'm not going to be using that as an assumption because it's not completely specified there, clearly. The total shown for each coffin, which is a killer cage, is the sum of the two values of the cells contained therein. So it's similar to basically a normal killer cage, but except for the sum of the digits, you have the sum of the values of the cells that are in the killer cage. So if the value of this cell were, say, a 6, this would have to have a value of 3 here to add up to 9, right? So that's how killer cages work. Remember, they're values, not digits. And along green lines, adjacent digits must have values that differ by 5 or more. So, on green lines, these are whisper 5 lines, as I like to call them. They're also known as German whisper lines, but I like calling them whisper 5 lines. So the values have to differ by at least 5. So, for example, if this were 3 here, this value, well, so this obviously couldn't be able to work because of the killer cage. Say this was, actually, let's use this. Say this was a 3 in value. This value of this cell would have to be 8 or greater. And it could be greater because of vampire cells, so keep that in mind. Say we had a 7 here. The value of this cell would have to be 12 or greater, or 0, 1, or 2. Because those are the only values which are 5 or more away from 7. So again, this could be 12 or more in value, or 2 or less in value. 2, 1, and 0, essentially. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, for the cages with for the boxes with 2 complete, or actually with the rows and columns and boxes with 2 complete cages or coffins within them, we know where the vampire and the victims have to be. They have to be in those cages. So we have both the vampire and the victim have to both be in row 1, have to be in these 2 cages. So that eliminates possibilities for vampires and victims in row 1. In column 9, we know these are vampire and victims, so this cannot be here. In box 4, we know this is vampire and victim, so the rest cannot be. In box 6, we know these are vampire and victim, so the rest of the box cannot be. This is 1, and one of these is 1, so the rest of this box cannot be. We have two coffins only in column 7, so these can't be victim or vampire. Both of these have to be victim and vampire, so these cannot be. Same with box 8, we have victim and vampire, so these cannot be. This is definitely 1. This is the other, so this can't be victim or vampire. Box 7, we have victim and vampire there. And let's see, column 4, we have victim and vampire here, so these can't be victim and vampire. So box 1, one of these is victim and vampire, the other one's there, so this can't be. This is definitely one of victim and vampire, so are these two, so these cannot be. This is definitely victim and vampire, so is this. Therefore, this can't be. And so this is one victim and vampire, this can't be, so none of the rest of the box can be. This can't be victim and vampire, because one's here, one's here. So let's start choosing. So for 2, to add up to 2, it has to be a vampire. Okay, so 0 plus another digit can never add up to a 2-digit number. So this has to be vampire as one of these. So this is vampire and this is victim, which forces this to be vampire. This is definitely victim, so this cannot be victim. This is vampire, which means this can't be vampire. So this is the this is a normal cell here. Let's make all the gray cells, green's not great either. Pink is going to be normal. So one of these is the victim. Again, to add up to 16, one of these has to be vampire. These are both victim. So where's the vampire in column 1? It has to be here. So this is vampire, which means this is normal, and this must be victim. So one of these is pink also. So we have one of these is vampire. One of these has to be, this has to be vampire here. So this can't be vampire here. So it's vampire here. This has to be vampire here. This can't be vampire because of vampire in the column. So this is vampire here, which means this must be vampire here because it cannot be vampire in, yeah, this is a 2-digit number. Okay. This has to be a victim because it can't be vampire anymore. Therefore, this is vampire, this is victim. This can't be vampire or victim, so this is normal, which means this has to be victim here. One of these is victim, the other one is normal, same with this. Okay, so the value of here is 0. And you have to have a 9, having the cage add up to 9. So this must be a 9 here. Okay. The thing is, so on a Whisper 5 line, you can never have a 5 on a Whisper 5 line in normal Sudoku. So therefore, since these are all normal, 5 can't be here. 5 has to be one of these two. We don't know what with. So 5 is guaranteed to be here as a value. And then we have it with another digit, and then this digit. So it has to be 5 with 1, 2, 3, or 4. So this is 5 in value with 1, 2, 3, or 4 to add up to 10. This is a value of 0, so this must be a 7 here. This is a value of 0, so this must be 8 here. This is a value of 0, so this must be 7 here. This is, one of these is a value of 0, the other one is a 4. So this is 4, this is 4. This is 4 in value with a 0. This is 6 in value with a 0, so this has to have a 6. This is 2 in value with a 0, so this must be 0 here, and this, sorry, the value of 0, so this must be 2. Okay, so this cannot be a 2 here. So you have 9 and 0 here. Where can the 4 be in this box 5? 4 can only be next to 9 or higher on a Whisper 5 line. So 4 is either one of these two digits, or it's next to the vampire, which could be greater than. So 4 has to be one of these 3 digits there. Okay. Vampire is one of these two, and the other one is normal. Same with this. Okay. This is 7, 0. So this has to be a high. It could be 5 through 9. Right. So 5 had to be here. It could have. Actually, that's not true. 5 actually. Ooh. 5 could be here, technically. No, 5 cannot be here. If 5 were here, this would have to be a vampire of 10. But then this would have to have a value of 0, which is impossible. So we showed that basically the way that the cages worked, that you cannot have, obviously, a vampire and a victim in the same cage. So that's obviously going to work there. Where is the 4 in column 3? Cannot be here because one of these is 4 with 0 to add up to 4. Same with this, so can't be 4 here. So 4 has to be one of these 3 digits here. Okay. So this is going to be... This has to be 9 or less here. So this is a high value, which makes this a low value, which makes this high, low, high, low, high. That means 6, 7, and 8 have to be here. And 6 can only be next to... So again, this is value of less than 10 because you have another digit plus the vampire to add up to 10. So it must be a high value. Because it has to have a 5 at least. Because again, 5 cannot be next to a normal digit in normal Sudoku on a Whisper 5 line. But if we try to have a 5 here next to this vampire, the vampire can only be 9 at most. So it can't be 5 here, so 5 has to be one of these two. So again, since this is high, this is low, high, because you always alternate between high and lows on a Whisper 5 line, and these are normal, right? And this is at most 9, so that's essentially acting as a normal digit. So this is high, you have low, high, low, high, low, high, and these are normal digits, which have to be high, which are 6 through 9, and we already have a 9 in the box. These are next to 2 unique digits, so they can't be 6, so 6 has to be here, which forces this to be a 1 then. Oh, this 4 here means neither of these can be 4. And because of that, we know 4, again, can only be next to 9 on a Whisper 5 line. In normal Sudoku, it could also be next to the vampire, but the vampire can't be greater than 9, and we can't have 4 here because of a 4 in the column, so this has to be 4 here, which makes this a 5. So this adds up to 9. 9 plus 1 adds up to 10, so this is 1. 1 is next to 7 or 8. This is 7 or 8. If you're next to both 7 or 8, it cannot be 3, which is the remaining digits, 2 or 3. So this must be 2, and that forces this to be 3. 3 can only be next to 8 out of 7 or 8 on a Whisper 5 line in normal Sudoku. So this is 8, this is 7. Okay, so again, the vampire is value 9. So 9 plus 1 adds up to 10. Remaining digits. This is a vampire. These are normal digits. 5 can be next to the vampire. Okay. Let's do remaining digits in column 4 then. We have 2, 4, 8, and 9. And none of these can be 4. Because a 4 has to be one of these. So 2, 4, 8, and 9. 2, 4, 8, and 9. Can this be 9 as a victim? And the answer to that is no. If you have 9 as a victim here, these 2 digits here would have to add up to 3, which is 1 and 2, but we can't have a 2 there. So this cannot be 9 here. We have 2, 8, or 9. If it's 2, that means this is 7, 8, or 9 here. If it's 8 or 9, this could be 1 through 4. Same with here. So this is just normal Sudoku with a Whisper 5 line. This is value 0, so this must be 5 through 9 there. And 5 cannot be here because it would have to be a normal Sudoku digit here. And 5 can't be next to a normal Sudoku digit. Let's see. If you have 8 here, this could be 1 and 3. And that would work. 2, 8, and 9. So 2 would be next to... So if this is 2, it can only be next to 7, 8, 9 in normal Sudoku and on a Whisper 5 line. This can't be 7 or 8, so it would have to be 9. If this is 8 or 9, this would have to be 2 or 3 next to it because it's normal Sudoku. So 9 would be next to, this is next to, not next to 2 unique digits. So this could technically be 4. Actually, where is the 4 in column 6? Can't be here because one of these is 4 to add with the 0 value to add up to 4. Can't be here because these are filled out, so 4 has to be one of these 3 digits. Okay. This is value 0. It's next to 2 unique digits. And this value could be a 5. This has to be greater than 5 away from 0. And it cannot be 5, 8, or 9. So this is 6 or 7 here. That's interesting. Okay. 4 is already in a victim cage, so 4 cannot be here. And 4 cannot be here. Okay. 4 is here. Where is 4 in row 5? Can't be here. Can't be here specifically because of one of these has to be 4 to add up with 0 to add up to 4 in the cage. Can't be here. These are filled out, so 4 and can't be in the victim cage, so 4 has to be one of those 2. Where is 4 in box 9? Can't be a victim, can't be the 6 here, can't be here, so 4 has to be one of these 4. Well, if this was 4 here, it would be next to 2 unique digits on a Whisper 5 line, or a 0, which is not possible, so this can't be 4 here. So 4 could be here, 4 could be here, or 4 could be here. Remaining digits in row 4. We have what? 1, 3, 6, 7, 8. Okay, this can't be 7 because of 7 in the column. 1, 3, 6, 7, 8. 1, 3, 6, 7, 8. 1, 3, 6, 7, 8. Okay. Where's 2 in row 6? Can't be here because 2's in the boxes, so it has to be one of these 3 digits. Okay. Where's 7 in row 2? Can't be here because of the 7's in the boxes, so they have to be one of those 3. And in box 8, it has to be one of these 3 because it can't be 7 here or 7 here. Okay. Hmm. If this is high, this would be a 9, and this 2 would be 2, so this would have to be 3 or 4 here. Um, oh, that's interesting. So these two values must add up to 14. This is at minimum 6, so this value is at maximum 8. So therefore, these two digits must add up to, at maximum, 8. So we have 1 through 6 here, and this can't be 1. Interesting. Okay. Let's see, what else do we have? This can't be 4, obviously. This can't be 5. It can't be 4 because we already have 4 as a victim. This can't be 5 because we already have 5 as a vampire. Three digits adding up to 12. This is 3 digits adding up to 12 also. So that means these digits must add up. So this is, no, sorry, this is 17. Oh, never mind. I thought that's 12. If that were 12, that would be very restrictive. It's not, though. So, so these 3 digits add up to 17. We have these two and one of these digits adding up to 14. These 3 digits add up to 14. These 2 plus that digit adds up to 16. So is one of these two, and both of these digits add up to 16. Oh, that's interesting. They're on a Whisper 5 line, too. To add up to 16. Uh, um. Okay. That means the values. The values could obviously be 1 and 15, 2 and 14, 3 and 13, 4 and 12, 5 and 11. Um, Obviously, well, 4 can't be here. Because of 4 in the box has to be in the cage here. So it's 1 and 15, 2 and 14, 3 and 13, or 5 and 11. You cannot have 6 and 10 because that difference is less than 5, or 7 and 9, or obviously 8 and 8. Okay. This is 0 in value. It has to be next to 5 through 9 here. Cannot be 6, 7, or 8 because of 6, 7 in the row or 8 in the column. So this is 5 or 9. This is a single digit. So this cannot be 1 through 6 in value. I mean, technically it has to be at least 3 in value because 1 plus 2 add up to 3 at minimum. But it cannot be 3 through 6 in value because then this would be 9. So it has to be at least 5 away from 5. can't go down to 0. So then it has to be at least 10. So this is at least 10 in value. Therefore, this must be 6 or less in value. Cannot be 1, 6, 2, or 7. So this is 3, 4, or 5 here. Since this is 3, 4, or 5, this value is at most 16 minus 3, which is only 13. And 13 is not 5 away from 9. So it's neither is 12, neither is 11. So this cannot be 9. This is guaranteed to be 5. So this cannot be 5 here. So we have a 5 here, which eliminates 5 in the rest of the column. This is 3 or 4. 4 cannot be here, because one of these is 4 here, so this must be 3. So this is 3, and this adds up to 13 here. This is 5, value of 0, 6 or 7. This 3 eliminates 3 in the rest of the box. So we have 3 digits adding up to 14 in box 6. Also, 5 has to be one of these digits here. 3 has to be one of these 3 digits here. So to add up to 14, can you do it without 2, 3, or 5? Can you do it without a 1? That would mean the minimum of those 3 digits would be 4, 6, and 7, which is 17. So no, 1 has to be one of these digits here, which means this cannot be 1. So we're guaranteed a 1 and a 3 here in row in row 4. It both cannot be here, so one of these must be 1 or 3. So if this is 1 or 3 and is a low, 5 cannot be next to a low. 5 can't be next to a normal digit in on a whisper 5 line. So this cannot be 5. So we know 5 and the vampire cell are here because we already have 5 as the vampire cell. So this can't be 5 as a vampire cell here anymore. 1 and 3 could be next to this. This could be next to a 0. So this could be 6, 7, or 9 here. To add up to 14 with 3 digits, can you have it without a 4? Yes, you could have 1, 6, and 7. But if it's 1, 6, and 7, this can't be 1, 6, or 7 here. So it has to be 4 then. So this must be 1, 4, and 9. 4 obviously can't be here. 4 can't be here because of 4 in the column or the row. So 4 has to be here. And this is 1, 9 as a pair. 1 eliminates 1 here. So this is 9. That's 1. And that leaves this digit as 6 or 7 because it can't be 8 in this box. So the 6, 7 pair eliminates 6 and 7 in the rest of the column. This can't be 6. This can't be 6. This must be 8 then. So these 3 digits add up to 14. And we don't have 5, 6, or 7 available here. So at most then, this must be 3, 4, and 7 to add up to 16. So this is 3, this is 4, and this is 7. That makes this a 6. Remaining digits in, this can't be 4 anymore. So where is the 4 in box 9? It has to be here. So this is 4. We have 1, 2, and 9 remaining in column 9. 9 has to be next to the 1 or 2 on this whisper 5 line, so this cannot be 9. This is 1 or 2, which must be next to 6, 7, or 8 because it's a high digit. That has to be 5 away from 1 or 2. The vampire cell and the victim cell here must add up to 13. So it's either 5, 6, 7, 8. So it's either 5, 8 or 6, 7, adding up to 13 because we have a 4 already in the box. Because 4 can't be here because of 4 in this cage here. And we know this can't be 4 because it'd be next to a 0 or next to 2 unique digits on a whisper 5 line. And 4 can't be here because of 4 in the column. So this is not 4 here, which means this is the victim, because 4 cannot be the victim, and this is 4 and normal. So this can't be victim here. So this is normal, which means this can't be normal here. This is not the 6. The 6 has to be here, which eliminates 6 here also. So it can't be 6 and 7 to add up to 13. It has to be 5 and 8. And this can't be 8 because of 8 in the column. So this is 5, which makes this an 8. To add up to 13. 8 eliminates 8 here, so this is 7. That leaves this digit as a 3. Remaining digits in column 7 are 1 and 2. This 1 and 2 must be next to 6, 7, 8, or 9 normally. Can't be 7 or 9 because of 7, 9 in the column, so this is 6 or 8 here. So this is a high, which means this has to be low. And this can't be 6 because if this were a 6, that cannot be next to 2 or 3 on a Whisper 5 line. So since this is low, this is high, which means this can't be high, this is low. So 7 cannot be here. Whereas the 4 in column 6 can't be this cell anymore. Can't be the victim cell because we have 4 in the victim cell. Can't be here because 4 in the column. So 4 has to be here, which means this vampire and this victim must add up to 12 minus 4, which is 8. Cannot be 1, 7. Could be 2, 6, or 3, 5. Well, this can't be 6 because of it's next to a 2 or 3 on the Whisper 5 line. So this is 8, which forces this to be 9. This can't be 9 anymore here. 3 cannot be. So again, 2, 3, 5, 6. 3 and 5 cannot be victims anymore because we already have 2 victims there. So this must be 2 or 6, which means this is 2 or 6 to add up to 8. To add with the 4 to add up to 12, that 2, 6 pair eliminates 2 and 6 in the rest of the box, so there can't be 2. This is 3. This can't be 3 because of 3 in the row. That leaves the remaining digit as a 5 in box 2. Okay. 4 can only be next to 9 as on a Whisper 5 line, so this is 9. We have 2, 6, and 7 remaining in column 5, but we can't have a 2 in box 8 because of the 2, 8 pair in box 8. So this must be 6 and 7. The 6, 7 pair eliminates 6 and 7 in the column, so this can't be 6. This is 2, which forces this to be a 6 here. Remaining digits in column 6 are 1, 3, and 5. 5 cannot be next to 9 on a Whisper 5 line as normal. We also know 5 cannot be a vampire because we already have a 5 as a vampire. Therefore, this must be a 5 here. This must be 1, 3, and 8 to add up to 12. So this is an 8, which forces this to be 2. This 2 eliminates 2 in the rest of the row. Remaining digits. So this can't be remaining digits in row. Remaining digits in row 5 are 5, 7, and 9. Well, 5 and 9 already adds up to 14. So it cannot be these 2 digits there. This has to be 5 and 7 then, which forces this to be 9. To add up to, this can't be 7 or 8. So 6 is going to be one of these digits. If this was 6 here, that would force 1 to be there as a normal digit, which is not possible because we already have the 1 accounted for in row 3. So this cannot be 6. This becomes a 1, 3, 1, 3 pair in row 4, which eliminates 1 and 3 in the rest of the row. This can't be 1 or 3. This is 6. The 5 and the 7 must add with the 2 to add up to 14. So this becomes a 2, 4 pair here. Therefore, this has to be an 8 as the remaining digit. 613 has to be next to 6 through 9 and cannot on a Whisper 5 line normally. So this has to be 8 or 9 because it can't be 6 or 7. This can't be 8 or 9 here. Okay. So we have a 2 as a victim, a 1, a 3. We need 7 as a victim, and 7 cannot be the victim here because we have a 7 in the row. This 2 eliminates 2 here, so this is 1 and 2. That eliminates 2 as a possibility here. So 7 cannot be the victim here. Where is 7 as a victim? It has to be here. Which eliminates 7. So this is a 4-7 pair, which eliminates 4 and 7 in the rest of the row. This can't be 7. This is 6. That forces this to be 7. This is at least 9 in value, but it must be 5 away from 6, so therefore it must be 3 and 8 to add up to 11, which makes this 1 here. So 3 and 8 add up to 11, which is 5 or more away from 6. 1 eliminates 1 here, so this is 2, which eliminates 2 here. So this is a 7 here as the victim. This is 2, which forces this to be a 9 as a victim here. Because we have 1, 3, 4, 5, 6, and 8. Remaining digits, we have 7 as a vampire here. We can't have 1 as a vampire here. This has to be then 1. So this is 1 as a vampire, because we don't have 1 as a vampire anywhere else in the grid. 1 plus 7 plus 9 adds up to 17, so this is 7. 1 eliminates 1 here, so that's 4. This 9 eliminates 9 here, so this is 8. 1 eliminates 1 here, so it's 3. 3 eliminates 3 here, so this is 1. Oh, we kind of knew that this had to be 6, 1 as a pair, but anyways. Remaining digits in row 9. Well, let's do remaining digits in row 7. This has to be 1 or 9. Cannot be 9 because of 9 in the column. So this is 1, which makes this 9, which makes that 1. Remaining digits in row 9. We have 3, 6, and 8. Okay. 6 and 8 cannot be the digits here because that adds up to 14. We have a 7 as the victim here. So the 16 minus 7 is 9. And 3 and 6 add up to 9. And this can't be 6 or 8. So this must be 3. And this must be 6, which makes this 8. 6 is obviously the vampire because 3 cannot be. So then 6 is vampire, so this can't be vampire here. So this is normal, which forces vampire to be here. 5 cannot be the vampire, so this is 7, which makes this 5. This can't be 7, so this is 4, which makes this 7. 4 is not the victim here, so this must be victim here, which means this can't be victim. And this is victim here. So this is 2 as the victim, this is 4. This is value 0. It has to be next to 5 or 9, and cannot be 9. Can't be 6, 7, or 8 because 6, 7, or 8 in the row, so this must be 5. This can't be 2, so that's 9, which leaves 2 here. Okay, and now we fill out the rest of the Sudoku by just normal Sudoku. Actually, this has to be 5 away from 7. It has to be a 2. So this is, we already knew that actually though, because we had 8 2s. That was the last 2. We have all the 1s? I think so. We have all the 2s now. 3s. We have 8 3s. We know where the last 3 is. It has to be there. 4s. We have 9 4s. 5. 5 in box 1 cannot be here, so it has to be here. And that gives us 8 5, so we know where the last 5 is. It's here. 6s. 6 in box 1 has to be here. We have 8 6s. We know where the last 6 has to be. It has to be there. Sevens, we have 9 7s. 8, we should have 9 7s, and then 9 is the last digit. So that's 9. Yeah, fairly straightforward. Just go through it slowly so that I can explain the logic behind it. I think I would consider this between easy and challenging, though. It's not... Unless you're used to vampires, which I don't think most of us are, it takes a decent amount of logic to think through all the possibilities, right? So I think that makes it a little bit harder than easy, but it is what it is. Anyways, I hope you enjoyed today's solve, and I'll see you next time on Frank Puzzles. Take care.